Hey, it's Dan. I'm glad you came here to get some math help. Let me ask you to do something before we watch the video. Please subscribe and like this video. Let's do the math.
Let's graph f of x equals this. So this is a quadratic and it's in intercept form. So if I'm going to graph this, the first thing I'm going to do is notice that this term out front here is negative, so it is opening downward. That's going to be good to know before we even get started. So this does open downward. And then what you do is you take these factors and set both of them equal to 0. Now I don't need to set the -2 equal to 0 because it doesn't have a variable with it, but I have done the other one. So if you solve that, you're going to add 1 here to both sides. These are going to cancel. You get x equals 1. And then you subtract 3 from both sides here. You get x equals -3. So these are the x-intercepts. And they're also called zeros. So x-intercept and zeros are the same thing. Usually when you're talking about x-intercepts, you're talking about a location on the graph. Whereas when you use the phrase or the term zeros, you're talking about what causes the problem to be equal to 0, or what makes the problem equal to 0. So those are the x-intercepts. So this is intercept form because it gives you a really easy way to find the x-intercepts, and there they are. So the next thing that I do is I take those x-intercepts and I plot them on the graph. So we said it was +1 and -3, so I plot those. And then I find the midpoint between those two by adding those two endpoints together and dividing by 2. So -3 plus 1 is -2, and you divide it by 2 to find the halfway point. So the halfway point is here at -1. So this is at -1. I draw a dotted line down the center. That's called the axis of symmetry, AOS for short. So the axis of symmetry is at the line x equals -1, and I draw that as a dotted line. Excuse me. And then what I do is I need to find this vertex point. So the vertex is going to be what y is when you substitute -1. In other words, you substitute this x value here into the original equation. So the original equation was that. So if I put that in here, I'm putting -1 in x's place, there and there. Of course, that's -2, that's +2, and I multiply all those together, I get 8. So that's why the vertex is at the point -1, -8. So -1 and +8. Did I say -8? So -1, +8. That's the vertex. And you go over -1 and up +8 there. So that is the vertex, and I've labeled that. And if I were doing this on a homework or test, I would label that up there too, but this will suffice for us. So that's pretty much how you graph that. And so then you draw this down through those x-intercepts. So this is going down and it's going to hit those x-intercepts. So you can just kind of shape it out there. It doesn't have to be perfect. Now, if your teacher wants some other points, you can make a table of values and plug in some other points. Now I picked 0 because 0 is here, and then I picked -2 because -2 is there, and I did the math on those. In other words, I put these x values into the original equation, and I did the math. So I end up with this, and that multiplies to be 6 on that one. And then I did this one here. I put -2 in. This is -3, this is +1. You multiply those together, you get +6 there. So I have 0, 6. So 0, if you start here and you go over 0 and up 6, you can see that's about right up there. So 0, 6 is on the graph. And then I have -2, 6. So -2 and up 6 would be about right there. So these are two other points that are on the graph. That'll help you to draw a more accurate picture. Now, there are some other things that you can do, but this is the basics of drawing the graph. Some teachers want you to find the domain and the range, and they want you to find the end values and stuff like that. If you look around here on my channel, you'll be able to see some things that if you search for finding the domain of the range and end behavior, you can find that on there. And perhaps I'll do another video pretty soon where we do that as well. All right, see you later.